Space has long captured humanity's imagination, offering boundless opportunities for discovery and innovation. Despite centuries of study, we've only scratched the surface of its mysteries. While 12 astronauts walked on the Moon during NASA's Apollo missions, the last of which occurred in 1972, much about our lunar neighbor remains unknown. In recent decades, unmanned missions have taken the lead in exploring the Moon, unearthing discoveries that continue to astonish scientists. One such mission, China's Chang'e 4, achieved a historic milestone by landing on the Moon's far side, a place no human has ever visited. During its expedition, the mission uncovered a strange and puzzling discovery that left scientists around the world both excited and perplexed. During the space race of the mid-20th century, the United States and the Soviet Union competed to achieve milestones in space exploration. The Soviet Union was the first to land a human-made object on the Moon in 1959, while the United States followed with the first manned lunar landing in 1969. These achievements marked a golden age of lunar exploration, but by the early 1970s, human missions to the Moon ceased, leaving robotic missions to take over the task of unraveling its secrets. China's Chang'e program, named after a Chinese moon goddess, represents a modern era of lunar exploration. The program's multi-phase approach has aimed to gradually advance lunar technology. The first two phases involved orbiting and landing on the Moon's surface. Chang'e 3 successfully landed on the Moon's near side in 2013, paving the way for the next phase of exploration, investigating the far side of the Moon. The far side of the Moon has always been shrouded in mystery. Due to tidal locking, the Moon's rotation is synchronized with its orbit around Earth, meaning the same side always faces us. This phenomenon has left the far side largely unexplored, visible only through orbital images and satellite data. Landing on this hidden hemisphere poses unique challenges, particularly in maintaining communication with Earth. Radio signals cannot penetrate the Moon's bulk, necessitating the use of relay satellites to transmit data. Despite these obstacles, China's Chang'e 4 mission aimed to make history. Originally designed as a backup for the Chang'e 3 mission, Chang'e 4 was retooled with enhanced scientific objectives. It included a lander, a rover named Yutu-2, and a relay satellite to facilitate communication with Earth. The spacecraft launched on December 7, 2018, and entered lunar orbit 5 days later. On January 3, 2019, Chang'e 4 successfully touched down on the Moon's far side, specifically in the von Karman crater within the South Pole Aitken Basin. This achievement marked the first-ever soft landing on the Moon's far side and was hailed as a groundbreaking accomplishment in space exploration. NASA Administrator Jim Bridenstine congratulated the mission, calling it an impressive accomplishment and a first for humanity. The scientific potential of this mission was immense, as the South Pole Aitken Basin is one of the largest and oldest impact structures in the solar system, providing a unique window into the Moon's geological history. Shortly after landing, the Yutu-2 rover began its exploration of the lunar surface, snapping photos and analyzing the terrain. Its primary mission was to study the composition and age of the Moon's far side, an area never before examined from the surface. Each day, the rover navigated the cratered landscape, capturing high-resolution images and using its advanced instruments to gather data. On July 28, 2019, as the rover prepared for its routine midday shutdown to avoid overheating under the sun's intense rays, something unusual appeared in one of its panoramic images. A member of the mission team noticed a peculiar substance inside a small crater. Unlike the surrounding gray regolith, this material was dark, shiny, and had a gel-like consistency. The discovery immediately piqued scientists' curiosity. The rover's route was postponed so that it could focus on investigating the mysterious substance. Using Yutu-2's visible and near-infrared spectrometer VNIS, researchers conducted a detailed analysis. Initial findings suggested that the substance's unique appearance might result from its composition and formation process, but its exact nature remained unclear. News of the discovery spread quickly, sparking global intrigue and speculation. The Chinese state-run media outlet People's Daily encouraged readers to guess what the mysterious material could be. Hypotheses ranged from lunar lava to alien artifacts, but scientists focused on more plausible explanations. One prevailing theory suggested that the substance was not a gel at all, but rather glass formed by the intense heat of a meteorite impact. When a meteor strikes the moon, the extreme heat and pressure can melt the surface material, creating a glassy substance upon cooling. Similar phenomena have been observed on Earth, such as trinitite, a glassy mineral formed during nuclear tests in New Mexico. Planetary scientists supported this hypothesis, noting the substance's location within an impact crater. Walter Freeman, a physicist from Syracuse University, explained that meteorite impacts are one of the few processes that significantly reshape the moon's surface, given the absence of water, wind, or volcanism. The potential presence of impact glass in the far side's craters could provide valuable insights into the moon's history and the conditions that shaped it. This was not the first time unusual materials had been discovered on the moon. During the Apollo 17 mission in 1972, astronaut and geologist Harrison "Jack" Schmitt found orange soil near the rim of Shorty Crater. Initially baffling, the soil was later determined to be composed of volcanic glass beads formed during a fire fountain eruption nearly 4 billion years ago. This discovery highlighted the moon's volcanic past and provided a glimpse into its early geological activity. Inspired by the Apollo findings, scientists analyzing the Chang'e 4 data considered the possibility that the mysterious material might similarly be volcanic in origin. However, further analysis revealed that the substance was likely an impact melt breccia, a rock formed by the welding and cementing of fragments during a high-energy meteorite impact. In August 2020, researchers published their findings in the journal Earth and Planetary Science Letters. The study concluded that the substance was indeed an impact melt breccia with a dark greenish color and a shiny glass-like texture. Measuring approximately 20 centimeters by 6 centimeters, the breccia was composed of mineral fragments fused together by heat and pressure. This type of material is relatively rare on the moon's surface, making its discovery particularly exciting. The study also noted similarities between the breccia and samples returned during the Apollo missions, reinforcing the significance of studying past discoveries to interpret new ones. While the material was not as exotic as initial speculation might have suggested, it nonetheless provided valuable information about the processes shaping the moon's far side. The Chang'e 4 mission and its findings underscore the importance of continued lunar exploration. The moon serves as a natural laboratory for studying planetary formation and evolution, and its far side holds clues about the early solar system that cannot be obtained from Earth. By uncovering impact melt breccias and other materials, scientists can better understand the moon's history and its relationship to our planet. Additionally, the success of Chang'e 4 demonstrates the potential of robotic missions to explore challenging environments. The use of a relay satellite to maintain communication with Earth highlights the innovative solutions required to overcome the obstacles of far-side exploration. These technological advancements pave the way for future missions, including the establishment of a robotic research station near the moon's south pole, as outlined in China's lunar program Roadmap. As nations around the world continue to invest in space exploration, the moon remains a focal point for scientific inquiry. Missions like Chang'e 4 not only expand our understanding of the lunar environment, but also inspire the next generation of scientists and engineers. With planned manned missions and ambitious projects like NASA's Artemis program, the future of lunar exploration looks brighter than ever. China's Chang'e 4 mission has already made history with its pioneering exploration of the moon's far side. Its discovery of an unusual gel-like substance turned out to be a fascinating example of impact melt breccia, reminding us that even familiar celestial objects like the Moon can surprise us. As we continue to push the boundaries of space exploration, who knows what other secrets the Moon has yet to reveal?